And I don't know why the projector is not on. Oh, okay. I didn't press the button enough or something. Okay. All right, so today I'm not going to talk loud like I usually do since you're the only one here. Today we're going to talk about Zeek, which is an IDS. It stands for intrusion. Hi, how you doing?
Good. Not the room I'm looking for.
Okay.
Don't worry about it. Thank you.
Yep. By the way, do you want the door open or closed?
It doesn't matter.
Doesn't matter.
We're gonna do the same thing as last week, call it off at like 6.
Yeah.
I might need to go a little bit early because I've got some stuff to do.
Sure. But anyways, again, sorry to everyone who might be listening. I was late due to traffic. So anyways, intro to Zeek. It is an intrusion detection system. And as you can see, it was developed a long time ago. It was developed around 1995 by Vern Paxson. Originally, it was called Bro, and right around 2017 or so, it kind of changed to Zeek, okay? And the Bro was the original instance of this IDS was born because it wanted to do something more than things like snort. Okay, snort at one point in time was best in class, but snort, it was able to collect alerts and everything. Snort was able to do things that no one had ever thought of. But snort itself is, very, very old. It goes back to the it goes back to the origination of the Unix system almost. So they created Bro to create the ability to correlate. I have to do this again. I have to make sure my laptop doesn't sleep on me. So Bro, which ultimately became Zeek, is there to create to correlate a lot of data, session data, transaction data, extracted content data, stat data, and also the alerts that programs like Snort would do. Okay, so in other words, it is able to look at your network and look at your hosts like a computer. And the reason why it's able to do that is because Zeek it basically is a programming language. Okay, so in other words, the way we can gain insight into our network and the way we can gain insight into our hosts and the forensic evidence on the various objects is through things like variables and keeping track. So, if you've ever studied programming, and I'm sure everyone here has, since it's a 400 level or 4,000 or 400 level class, you know about things like data structures, discrete structures, like variables, hash maps, key value pairs. Well, Zeek is able to utilize those types of data structures to successfully, hopefully, explain what is going on in your network by the use of forensic evidence. Okay, so it keeps track. It utilizes metadata to keep track of things and create, as we might be able to call them, predictive knowledge. Okay, so the network. Now the question is, where would you place this NSM, or network security monitoring system? So there are like I said, there's various levels. Obviously, you could put it somewhere facing the your ISP, your internet service provider, or you could place it somewhere in the DMZ, or you can place it somewhere in your interior network. Okay, so in other words, we have a potentially layered type network, which is very popular with various, and I guess you could say various enterprise type networks. Examples of enterprise networks would be at basically every instance of the big three, GM, Stellantis, and moving down to all the automotives, Honda, Toyota, and a lot of the bigger players like Lear. Anybody that has a name out there that you've heard of, they generally have this multi-layered environment. For example, at Stellantis, they had several layers, 4 layers to be exact, and not really that organized. But it was basically like, okay, in the DMZ might be what they call the front-facing web servers. For example, Stellantis might have a web page simply dedicated to some charity, or they might have just a web page dedicated toward showing off their products and everything, so it's not connected to any particular database. That would be further inside of the network. Okay, so I'm just giving you an example of the uses of these various layers. Okay, so what would be the advantage of putting the network, the NSM or network security monitoring, in here in the DMZ so it could face directly into the internet? So as an example, you could know and understand, as they say, perimeter device compromise. Okay, you can see the top talkers in terms of what external IP addresses they could be going to, because that is post-NAT overload, or network address translation overload. So that is where your private IPs use the port numbers to translate to the WAN IP, and that was primarily employed in the late 90s, early 2000s to help save on IPv4 addresses. However, that was too late. I'm going to go ahead and close the door. Well, that's cool. Okay, now the disadvantage of placing the monitoring system in that's facing the internet. The disadvantage is you're missing many of the activities of your internal network. And I'd like to think that your WAN network, or your IPs that are facing the internet, facing the capital I internet, would be the big ideas in life. And when it comes to the almost, you can almost look at the internal networks as a bunch of clients, private IP clients, and unfortunately, you're missing the details. And a lot of the actions or a lot of the activity are coming from inside of your network, and that's who you really have to worry about. It's kind of like these companies that spend millions of dollars. Absolutely, they go bonkers on spending money on advanced security event management systems, security monitoring, the best firewalls. And it's just not the hardware. The hardware is the cheap part. The expensive part is the labor, hiring everyone to actually configure these things. They're out there hiring people with their CCIEs and their advanced CCNPs and everything. They're paying $80, $90, $100,000 a crack for teams of people to manage these devices. Meanwhile, you have somebody that in subnet 1 here, for example, that is downloading, an errant file, which could compromise everyone. So examples of some of the things that they might be missing by placing the NSM here are things like beaconing. Somebody may download a piece of malware that may send a beacon. The other thing is on this PowerPoint, it shows beacon and C2. Beaconing and C2 are almost the same thing, although beaconing is what is going on, and C2 is the actual piece of malware. So somebody downloads something on this in this inner subnet, and this malware is looking to connect to a command and control server outside somewhere. And so by placing the NSM on the internal network, they're actually, by not placing it in the internal network, they're actually not seeing perhaps the beaconing that is going on. Another thing they might be missing are rogue systems. So at one point in time, before there was internet everywhere, always on internet connections, and people walking around with cell phones with unlimited data and things like that, there was a time that not everyone had the internet at home, or if they did, it was dial-up. And so people would sometimes bring in their own wireless routers so they could hook it up to their work internet on their breaks. I'm not saying that they were doing anything wrong. I'm not even saying they were slacking off work, and I'm not even saying they were breaking policy, because, quite frankly, before cybersecurity was so ingrained in academia and so ingrained in every facet of work life and home life too, there were the policies that they had severely lacked the abilities of technology, and not just any technology, of the quote unquote burgeoning technology. Okay, and like I said, that was late 90s, early 2000s. Now in 2026, where we're at now, I mean, what was burgeoning technology back then is very commonplace now. Like now, homes are, if you pay a fee, it's very common to have a half a gig or 1 gig download speed at their house. At one point in time, it was a serial connection, 1.544 megabits a second, or 10 maybe, or something like that. Now you're getting, a half a gig or something like that. So it's crazy. So you wouldn't have that, but back in the day, you could have it. It would not be uncommon for somebody to bring in their own access point to take advantage of the good internet. And the problem, obviously, is they're introducing a brand new network, albeit a private network, but they're introducing a network that is unguarded, that may or may not have the proper, policies installed. You might be bringing in disinfected, you might be bringing in infected laptops and nodes and USB drives and things like that. So sometimes you can say all the action is on the inside. That's where the action is. So that's the importance of the security monitoring placement. So you decide where exactly you want to place it. So some of the modes of operation is in monitoring mode. That's one mode, and the other one is you can use Zeek against saved PCAPs. Okay, so and just so everyone knows, you might be leaving by this time. I'm also, when I go through this, after I get done with this PowerPoint, stay tuned because I'm going to go over the lab that will be assigned to everyone, and it's just installing Zeek, and it's just. Anyways, so we'll just go over that. So anyways, the monitoring mode it's showing the span command. So the span command allows something called port mirroring. So switches have it, routers have it, and you can even configure your Linux computer to have it, because remember, a router is, like a Cisco router or Juniper router is nothing more than a repurposed computer or PC. So anything you can do with a Juniper router or Juniper device, you can do with a PC or your Linux server. I'm sorry, I had the door open, but they started sawing or something in that room.
It's all good.
Yeah. They kept on distracting me. Anyways, so we were just talking about Zeek, intro to Zeek, and the fact that it's an IDS, and then we were talking about where you would place it and the risks and everything. So now the modes of operation, you can actually monitoring it, okay, using at least one interface or more interfaces through the port mirroring, and they use span as a key word, and to monitor a layer 2 switch, at least in Cisco, you literally have to use the span command. I don't know, have you ever done that?
Yeah.
Well, oh wow, okay. What class was that?
I took it all the way back in Washington when I met with forensics there.
Oh, okay, cool. All right, and you can run Zeek, okay, against saved PCAPs. Okay, so anyways. Okay. Okay, so there are two type of log formats with Zeek. There is tab separated values, and then there are JSON files. There are positives and negatives to both. Tabular separated values are better for localized analysis, like short-term analysis, okay, and long-term, but long-term storage, okay. JSON, okay, it is better for like event management, like security event management. So a CIEM server, it allows you to store a bunch of events in the long term, and then you can run correlative studies on them. Like, for example, you can research the amount of network activity or top talkers prior to a malware event. or prior to a DDoS attack. One of the differences between these log formats is that JSON takes up a little bit more storage, okay, and it's easy to see why. The tab separated values, they have columns. They only have one field for the column and the corresponding values for each column. And for the JSON files, it literally says the category name for each one. So this JSON is kind of like have you ever heard of a dictionary in programming? Yep. Java, they call them hash maps. Basically in JavaScript, they're called objects. And they're just basically, key value map. Now, the other thing I wanted to talk to you about is the fact that it's the way these, and just so you know, the tab separated values, this is the default method of display for Zeek. Okay. Now, just some details. This top header line is separated on two sublines or two headers right there. The first one is field, and the other one is type. Now recall that I mentioned that Zeek is a programming language, so this is where its programming colors are kind of shown. We have here the field itself, okay, and then we have the type. So we have the start, and it is of type time. Okay, we have the next field. Unfortunately, you have to go like this, and then this one you have to go like this. This is the connection ID. Okay, and the good thing about the connection ID, what Zeek allows you to do is it ties one single connection to possibly different events. So you can follow a complete connection from start to finish with ease. Okay, and so that's where some useful information can be gleaned. And again, so for example, TS to start, TS is a type time. So that it represents the amount of seconds after January 1st, 1970. And this is like milliseconds or whatever. And the UID, it's of type string. Okay? We have the ID of the origin host, and that is of type address. Okay? And then we have the ID of the origin port, and that is type port. See that? So, I know it can get, because the tabs are starting to get a little out of whack right here, it gets a little wonky, but, there is a fix to that. We'll talk about that in the next couple slides. Okay, so here is for JQ. Okay, you can actually utilize JSON, and then you can utilize the cat command. Okay, and you can get it to actually produce results, and you can actually get it to couple information in clumps like this. So this is an actual search term you can actually put or place in your command line. Okay, and again, we'll talk more about that in detail as we progress with the slides. Okay, so let's take a look at the log formats. Okay, so here we can utilize two forms of the keyword cut. So there is a keyword cut that comes with Linux itself. It's natural, it comes with Linux. There is another keyword called cut, and much like object-oriented programming, when you call cut, the term cut, and you are in the Zeek directory, it takes on it almost like adopts or inherits the cut meaning or reference that Zeek has. So the Zeek form of cut is kind of different than the Linux form of cut, but yet they are the same. It's kind of like if you've ever studied polymorphism in programming, in OOP. So the global or super, quote-unquote, definition of cut is Linux, the Linux version, and you say cat, meaning you're going to stream the entire con log, and that's connection log. And just so you know, like so you know, like when you create network traffic, one single Zeek pass can produce like a half a dozen different logs that overlap. Okay, so if you're using HTTP, for example, to make a request, Zeek will take it will create a number of logs based on that one single request. So for example, if you use HTTP to request a certain file from a server, okay, it will create the connection log. Now the connection log is like the origin log. The connection log starts everything, and everything is based on the connection log. Okay? And then it will also create an HTTP log using that same connection, that one request. And then it will create a file log in which Zeek will try to guess based on the file MIME data of what type of file it is, and possibly a file name, although that's not always guaranteed. But at least you'll get to know the type of file, and that's important for network forensics, because if you see like a DOS executable or something like that, that could be suspicious behavior. And again, you're using cat, and you're catting out, you're streaming the entire connection log, then you're using the pipe, and then you're using the Linux-defined version of cut-f, which is a flag, and you can specify the number of the column. But you have to go into the order that they say. So you have to know the order ahead of time. You can't do it any other way. So it's a little less flexible. The more flexible one is the Zeek-cut definition. Okay, so in here, as you can see, that the reason why it has to do /opt Zeek bin Zeek-cut is because he did not put that in his path, but nevertheless, here Here you can just specify by the name of the tab separated value column name, you can specify just the information that you want to see. So here he wants the origin bytes, response bytes, origin IP bytes, response IP bytes, and that's exactly what he gets. So if you only have 4 or 5 columns, it gives you a nice, neat columnar format, and it's easy for correlative analysis. Okay. My mouth is kind of dry. Let me just get a drink of water. I'm just going to take this drink from the water fountain. I'll be right back.
This is a pretty dead class.
How the hell do you guys know we had class today?
I guess we have class now. It started last
How'd you
week.
know? How did you
He
find
sent
out?
an announcement like 2 weeks ago.
He did?
Yeah. Lost some question.
Yeah, because I saw the he posted the canvas thing. I was like, why would he do that? And I saw the video. I was like, he's here now. Very interesting. But
Awesome.
yeah,
Have you done like your rundown classroom stuff yet? Or no?
I already did most of it. Yeah.
How much of it do you need to do? Do you need to do like just one group, or do you have to do like all 8 of them?
I have no idea because I did most of mine through my military, so it just automatically counts for my credit. Sorry, I don't know.
No, that's fine.
I mean, it'd be real simple if you just joined the military. So.
Hey.
Tall order, man.
Okay, so here are some of the log files in Zeek. We have the con log, DNS log, files log, FTP log, HTTP. Okay. SSL log. Now, SSL log is a little misleading because SSL obviously is a deprecated certificate for HTTPS. But SSL log also as the Zeek people considered, basically TLS is just an improved version of SSL. So the TLS information will still be in the SSL log. We have the HTTP log. Well, now the HTTP log would consider HTTP v1 and v2. Quick log is basically HTTP3, which rides over UDP. Whereas HTTP v1 and v2 ride on TCP. And we can see that there is a certain evolution, if you will, of Zeek, because many of these were in the first instance of Zeek, but LDAP was originating in 6.1, LDAP search log originating in 6.1, Postgres SQL log originated in 7.1. Okay, but as I said, that one event, even 1 or 2 requests, can result in more than one log. Like I said, so you send a file over HTTP, and then you're going to get a bunch of logs emanating from that one single request. Okay, let's talk about timestamps. So the timestamp or start, some people would call that start, is because the timestamp is the epoch time of when the event started. Okay, now it's not necessarily the connection, because you don't necessarily have to have a connection to have an event. You might have a connection that was attempted but was unsuccessful, like a UDP type connection or a missed TCP three-way handshake. And you want to keep track. But even a missed event would be an event nonetheless, or a missed connection would be an event nonetheless. And sometimes those missed events tell more of a story than the actual connections. Okay, for example, think of it like a criminal, or you're investigating a criminal case. So let's say you are a security guard for EMU campus, and you see a person who you've never seen before trying different office doors to no avail. So it's an attempt, but no success. And then you find out that after your shift is over, you come back, and then somebody robbed one of the computer labs. And suddenly the security guard remembers this shifty-looking guy trying offices and doors, and to no avail, like he didn't know where he was going. And suddenly, that is a significant piece of information. And again, we can see here we have we have the start here, and notice there's no end. Okay, it only shows the timestamp only shows the start, of the event. So what you can do is you can see where the start is, and we can see the duration right here. So if you simply add the start or the timestamp and the duration right here, and like in this case, you're adding 1599, whatever, plus 162 seconds, then you get the complete transaction time. Now, the other thing I wanted to present to you is you notice that there is one con or connection ID. You can see that they all end in YUC, but yet there are multiple events here. And as a matter of fact, there's one connection ID here. As you can see, they all end in AYU lowercase c. Okay, and you can see 3 different times, and that is because it begins with a request, a TCP request to HTTP TCP request here, and then it took time for the server to actually send out and receive the information, and they had to return, they had to acknowledge. So because of that, there are 3 separate timestamps for the same connection. Okay, so we have here the unique connection ID. Okay, so the connections for tuple of endpoint addresses and ports. Okay, so host address of the originator, port associated, host address of the responder, and port associated with the responder. So these generally is a part of a tuple or tuple of the unique connection ID. And then we have the unique file ID, or FUID. Anyways, so we have HTTP log, we have file IDs associated with, for example, uploads, the same thing for downloads, Okay, and then we have a PE log associated with what they call portable executable, like Microsoft files. And then we have parent fluids. Those are container files for things like zip files. So here we can actually observe, any files that could have been transferred, and what we're really looking at is things like names. But even so, even if we're not able to see the names, we can see perhaps the type of file. And as I said, if there is a strange extension we've not seen, that could be troubling. And if it's like a DOS type file, that could be troubling as well. Okay, so as I said, it all starts with a connection log, and from the connection log, if your search needed DNS resolving, you have if the information will be copied, or whatever will flow from the con log to the DNS log. And if there's any files, it will you're going to get information in the files log and the portable executable file log, as well as the HTTP log, and any alerts or notices will be there as well. Okay, things like X509 that keeps track of your X509 certificates, SSL log, files log. Okay, so it kind of originates from the con log. Okay, so within the con log we have proto, which is transport layer protocols like TCP, UDP, but it also can be ICMP, so you can keep track of all the different requests. Here we have application layer protocols such as DNS, HTTP, duration, number of payload, the connection state, okay, whether it's local or it's remote, missed bytes, history. Okay, here we have different connection events, and as I said, a connection event does not need to be a connection occurred. So this is an advantage of placing. This is one of the advantages of placing the sensor, if you will, on in the internet or WAN facing area of your network, because you can track all of those missed connections and create an event digest based off of that, because as I said, a missed an errant or a bunch of errant sync packets or something like that might tell more of a story by keeping track of everyone inside of your network. Okay, so does anybody, if you take a look at here, this is basically, this might tell a story right here, but the problem is, the issue is that it may be, we have source and we have destination, so there's no kind of like back and forth. It's all going from one source to the same destination. How we look at this is more normal, if you will. This is like bidirectional. So we have source is 10.9.11.101 to 205.185.119.20, and then we have this goes to here. So it's like ping pong, if you will. So it's bidirectional, and that's what we associate as normal. It looks like it's Wireshark kind of a thing. Yeah. Oh, I'm sorry, what?
Could I attempt to give what I think went
Yeah.
wrong with the first one? Well, I noticed that the client was sending all that traffic to the server after they server wasn't sending anything.
Absolutely.
So I almost wonder if the users initiate like a DDoS.
Yeah, absolutely, absolutely. But I just wanted you to understand that we're trained to look at things bidirectionally. And here, this is just the way Zeek lists everything. We have the originator and responder. Doesn't matter which side it's on. It just is originator and responder. So just to get you used to how Zeek actually lists things. All right, let's take a look at local versus remote. Now, local origin, okay, and local responder, those are trues and falses. That's the return type of this. And so when we have a origin host and the response host, okay, the local origin host is true because it is local. It's a 10.9.11.101. And for the response host, it is false because it is 104.78.120. So it's not local. Okay, so the only time local origin and local response are both true is when they both happen to be local. Okay, so statefulness, TCP versus UDP. Even though UDP is seen as stateless versus TCP, which is stateful, meaning that that it tracks whether or not the remote server is up or not. Just because UDP is stateless, your Zeek analyzer will still track the connection. So in other words, if you do something like cat DNS log and run through the Zeek cut command and you mention all the category names here, you're going to wind up with both the initial request and the response in the same line for UDP. Now let's take a look at files over the wire. Okay, we look at files.log. Okay, and file names may or may not exist. So they have a pe.log. And just so you know, Corelight is, so Zeek is the free version. That's the kind, obviously, we're going to be using. Corelight is the professional version. So we can just survive with Zeek. And then in terms of utilizing Zeek in an enterprise environment, we can essentially look at, we can run an enterprise and we can use Zeek or Corelight or whatever to, in terms of our network operations. So in other words, we can use it to audit our own system. So in other words, we can make sure that, for example, like even though there is an FTP extended access control lab this week, we will have, FTP, you should be alerted as to whether or not your enterprise is running FTP because, of course, that sends things in plain text. Okay, here's SSH. It keeps track of your SSH usage. So, for example, if you're using the old SSH v1, which uses it uses one singular certificate encryption or one singular certificate without changing, whereas SSH v2 is more secure and an improvement over V1. You should never use SSH V1 because it's very insecure. SSH V2 will actually change out the certificate midway through its lifetime, so it's harder to detect in using a network sniffer. And again, here's an example of where you can create and again, you're using Zeek cut because if you didn't use Zeek cut, this would be like almost like a cacophony of information. So with Zeek cut, we can create our nice neat little tabs right here. We have our version right here. We have our IP addresses. We have our ciphers and our server names right here. So again, well, anyways, let me get back to okay. So in this lab that I'm going to upload, you're going to install Zeek on OpenSUSE Tumbleweed. So now the reason why I'm asking you to install yet another VMware operating system, Tumbleweed, is because that is the most streamlined way to install Zeek, is to OpenSUSE Tumbleweed. Does that mean that you can't install it on Kali? Of course not. If you wanted to go ahead and install it on Debian even. There's actually executables for Debian 13, I think. From what I was able to do, OpenSUSE Tumbleweed is the best way to install it. It's quite simple. It's quite simple. Anyways, here we're using two VMware servers. One is Kali and the other is OpenSUSE. And we're just verifying the architecture with common Linux commands. Okay, and they're like when you install OpenSUSE Tumbleweed, you may wind up with nothing more than a command line interface, which is fine. I'll see you later.
Yep.
With a command line interface, which a lot of people love, but some people love a good GUI too. So here's the command to install KDE Plasma. And a lot of times people like their copy and paste from their host to their VMware. So it uses zipper as their install keyword. Whereas Kali is, of course, apt install. So here's how you can install VMware guest tools. However, it should already Tumbleweed should already have VMware tools installed, but if it doesn't, just follow those instructions. And also ensure your network adapter for your VMware is in bridge mode. That's the best way to ensure that everything is pinging, and make sure the Kali or whatever other VMware Fusion you're using, or whatever virtual server you're using is also in bridged mode. So you can make sure bridge was an old term for that's a legacy name for what we consider a layer 2 switch. So you will all be on the same IP address network. And so, if you want to utilize the ifconfig command, you can install the zipper install nettools deprecated. And here is we can install Zeek 7.0 on Tumbleweed. So here is the command. And then you do sudo zipper refresh and sudo zipper install Zeek 7.0. And then here you can verify the installation with the command which Zeek, and then Zeek version, and Zeek dash and then head. Okay, now you may run into the problem that you don't get any output of it. And so you're going to run these commands here, ls space ld opt zeek and ls opt zeek bin, and then you're going to run the version. And you're probably going to see the output that says Zeek 7.0. But the problem is, if you just run any Zeek command, it will not, even from sudo, it won't do it because it's not in the path. So you can run it from your opt zeek bin zeek directory, but that's the only place you can run it. So you need to place it in your path permanently. So that's the command to do that, right here, these two. And then you can do which Zeek and Zeek version to verify that Zeek is available. And then what you're going to do is you're going to prepare what they call a web target on Tumbleweed. So you're going to create an index.html file with a simple web page right here. And then you are going to run Python 3. You're going to bring up a web server in Python 3 with port 8080. Leave that terminal open. And then you're going to capture traffic on the Tumbleweed sensor. So you're turning your Tumbleweed virtual server into like a sensor. You're turning that into, an IDS. So what you want to do, you want to note your IP addresses. Okay, and you're going to, you may have to install TCP dump. Okay, and if you do, then you're going to run this command, your internet-facing IP address and the Kali IP address. Okay, and then on the Kali, you're going to run these commands, keeping in mind what to use, whatever IP address is your sensor, which essentially is your Tumbleweed operating system. And then you're going to stop the TCP dump on OpenSUSE. And then you're going to do a run. You're going to analyze the packet capture because this Tumbleweed case, okay, was created right here, okay, into a PCAP. So this TCP dump created this PCAP right here. And then you're going to run Zeek, and you're going to have it analyze it. And then you're going to list the log. And then you're going to have Zeek run through the Tumbleweed again. And then you're going to review the forensic evidence. So you're going to use the head command to take a look at the connection log, the DNS log, and the HTTP log. You should see at least those 3 logs. And then from here, you can actually utilize the my favorite thing is the Zeek cut command, and as I said, Zeek is a programming language first, and it uses polymorphism to actually define its own version of cut, and it refers to each header by name, and you can create this nice, neat graph right here. Okay? And I also have, here, 1 second. Let me just take a look here. Okay, so I also have another assignment right here. So this week you'll have this assignment, and you'll also have the Zeek assignment. And here's a little lecture right here, and that's it. That's it. Actually, I have another lecture I'm going to put there. So everything will be up. Like it takes me 2 hours to get home, so give me like an hour after that, so like 3 hours, and that's it. So that's it.